If 2 hours ago it was as long after 1 o'clock in the afternoon as it was before 1 o'clock in the morning, what time would it be now? All right, let you think about that. And let's go ahead and get those calculators ready. Get in your, push your y equals, which when you're in polar mode, it shows you the R1, R2, and so forth. So we're going to type in 3 times the sine of, and we need to put one more set of parentheses in there. 1 divided by 3, multiply that by theta, and then close the parentheses. The R2 is negative 3 times the sine of, again, parentheses 1 divided by 3, and then multiply that by theta. And let's adjust the viewing window. And if I went too fast, my apologies. So you can see the two functions there. 3 times the sine of 1/3 theta, and negative 3 times the sine of 1/3 theta. The 1/3 theta is inside the parentheses. Okay. So then again, adjust your viewing window. Theta min 0, theta max 2 pi. Theta step of pi divided by 24. And then x min is negative 6, x max of 6, x scale of 0, y min of negative 4, y max of positive 4, and a y scale of 0. Okay? So just run through that one more time. X's go from negative 6 to 6, y's go from negative 4 to 4, and the theta min 0 to 2 pi, and 0, and max 2 pi. Theta step is pi divided by 24. Okay, go ahead and hit graph. Kind of a cool graph. Got the yin and the yang. How anyone ever figured that out, I have no idea. But I wanted to show you a couple more. Go into your y equals. You're probably not even watching this. R1 equals theta, and just theta. Okay, so let's adjust the viewing window. Theta from 0 to 157, and the theta step is 0.8, x min negative 155, x max 155, y min negative 140, and y max 140, and that's it. And hit enter. It just keeps going and going and going. Now we're gonna mess with this a little bit. Okay, just to get you an idea of let's see. This is actually the first graph we're gonna be drawing on our own. So what I want to do is give you an idea of what it means R1 equals theta, or just R equals theta. Let's start our theta min at 0, and let's stop our theta, so we adjust our theta max to be 2 pi. So what happens in the first 2 pi radians? Okay, and the theta step, let's let it be 0.1. I'm just guessing. And x min, let's let the x min be negative 7, and the x max of positive 7. Okay, and let's adjust the y min to be negative 7 and the y max of 7 as well. Okay, let's see what happens. So that's what the graph looks like in the first 2 pi radians. Okay, let's look at what the graph would look like in the first pi radians. See if you can I guess just estimate what the graph would look like if theta only went from 0 to pi. So think to yourself, and let's adjust the theta step to 0.02. Okay, so it'll take a little bit longer. It'll take a lot longer. So there's 0 to pi. So that's what the graph of this function, r equals theta, looks like from 0 to pi. Okay, well, what do you think it would look like if we went from 0 to pi over 2? So we're doing a little experimenting here, and see if you can estimate what the graph would look like from 0 to pi over 2. It looks like that. Okay, and then let's just take it, instead of going from 0 to pi over 2, let's go from 0 to 4 pi. So if you can estimate what that would look like. Now we're going to have to adjust our x min to be, let's let it be negative 15. to 15. And the same with our y min, negative 15 to y max of 15. Now again, what we're doing is we're graphing r equals theta from 0 to 4 pi. Okay, you saw what happened from 0 to pi over 2, 0 to pi, 0 to 2 pi, and then see if you can figure out what would happen from 0 to 4 pi. Oh, I have the theta step at 0.2. It goes really slowly. So there's 2 pi right there, and look at the curve just keeps getting farther and farther away from the pole. Okay, and if you were to, well, we saw what happened when we went r equals theta. It just kept going forever. So anyway, that's what we're going to be graphing in the next video. So I will see you there.